Welcome to Two Projects. In this video, we are going to explain about the project that is post quality prediction for Stack Overflow website. Before getting into the execution, first let us understand what is the project about. Online communities like Stack Overflow and Reddit have become essential spaces for people to ask questions and share knowledge, especially in programming. These platforms bring together beginners and experts, creating an environment where knowledge flows freely. However, many newcomers they struggle to articulate their questions clearly. For example, they might post something vague like my program isn't working without providing any details or context. This makes it hard for others to help effectively. Initially, platform administrators could manage these issues by manually cleaning up or removing low quality posts. But as these communities grew up, the sheer volume of vague, repetitive, or poorly written posts became too much to handle manually. This strained the platform's resources and made it harder for users to find relevant information. Addressing this issue has become crucial to maintaining the quality and usefulness of these platforms. And when someone poses the questions that are unclear or lack enough details, it not only wastes the time of person asking but also the time of those who are trying to help. So, without any code or snippets, it is very tough to provide a meaningful answer. This leads to unanswered questions piling up the platform. As these platforms grow larger, this problem gets magnified. It is not just about few bad posts anymore, it is about thousands of them, which puts a huge strain on resources. This is where the idea of using predictive models comes in. If we can figure out how to assess the quality of a post automatically, maybe by checking how clear or relevant it is, we can filter out the low quality ones before they even go live. This would make the platform more efficient and improve the overall experience for everyone involved. So, this project is all about designing a system to tackle the problem of low quality questions on the platform like Stack Overflow. Think about how frustrating it can be when you are scrolling through a site looking for a solution and you come across poorly written questions that don't even make sense or provide enough details. That's where this project steps in. Here is how it works. The project processes the text of question and converts it into format that machine can understand, essentially turning words into numbers. For that, it uses something called doctwit, that is document to vectors, which is intelligent technique that because it doesn't just look at individual words but capture the meaning behind them. These numeric vectors are like summary of the question's content. Then these vectors are run through different machine learning models that are logistic regression, decision tree, random forest, and deep learning models like BERT to determine if the question is of high quality or not. The goal is simple: automatically filter out low quality posts, saving the time and making the platform better for everyone. So, to do this, this project uses the questions of Stack Overflow that has been taken from the Kaggle repository, and that questions are labeled into three categories accordingly, that is high quality, low quality edit, and low quality close, which is HQ, that is high quality, low quality edit is LQE, and low quality close is LQ close. Think of these labels as tags that tell the system how good or bad the questions are, making it easier for the system to learn from the data. And then the data has been converted into numeric using doc2vec. That is, the data will be converted into vectors using this doc2vec, and all the models are evaluated using accuracy, precision, recall, and FN score. To further improve the accuracy of the project, we have incorporated CNN 2D model, that is convolutional neural network 2D model, as the extension. This type of deep learning approach that can capture patterns in the data more effectively. Think of it as a tool that helps the system understand not just the words in a question, but also how they are connected and structured. This deeper analysis can improve how accurately the system identifies low quality questions. On top of that, we have built front end using Flask framework. This interface is like a gateway for users to test and interact with the system directly. To keep everything secure, we also have added user authentication, so only authorized users can access it. This step makes it easy for users to evaluate the system and also ensuring their data is protected. It steps towards making the whole system more practical and user friendly. Moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the necessary libraries that are NumPy, Pandas, sklearn, and deep learning frameworks. Then comes data loading part. So here the dataset containing Stack Overflow questions is loaded into the project environment for analysis and model training. Then comes the data pre-processing where we eliminate common words such as is and the that don't add significant meaning. Removing special characters. Strip symbols like hashtag or at the rate that aren't relevant for text analysis are removed. And here we clean up punctuation marks such as commas, exclamatory marks, etc. And then we convert the we convert all the categorical labels, that is HQ, LQE, L close, into numerical format by using the machine learning. And then comes text embedding generation, that is using doc2vec. Here we convert processed text into numerical vectors using doc2vec, capturing the semantic meaning of the words for better machine learning performance. Then comes data splitting. Here we divide the data into two sets. One is training and the other one is testing set. Training set is used to evaluate the model, build the model, and testing set is used to evaluate the model. Then comes model building part. Here we define the multiple machine learning models and deep learning models for quality prediction. After defining, we train those models with the training data set to learn patterns and distinguish between different question quality classes. And all the models which are trained will be evaluated using accuracy, precision, recall, and FN score. And coming to the part of front end, here a user interface is created using Flask with the registration and login features supported by an SQLite database for secure user access. And in the front end users, they will be able to give the questions related to Stack Overflow or any of their programming, and that will be pre-processed at the backend. It will be fed with the train model, and finally outcome will be displayed through front end. It displays the quality of the code. Moving on to the algorithms used. So here we have the algorithms used that are logistic regression, decision tree, random forest, support vector machine, naive Bayes, BiLSTM, Doctored BERT, and extension CNN 2D model. Moving on to the requirements to implement this project, we need some hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. Let us open that. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So let's open the dataset folder. So this is the dataset that we have used in which we have Stack Overflow questions. Is being buffered. Just wait for a while. Until then, let's minimize and check with the other files. So here in this test data, we have the test cases that we will be using in the front end for predicting the questions quality. Let's get back. And here in the model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files, and that will be loaded into the project code during runtime of the application. And here in this static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And the next file we have is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have is the notebook.ipynb file. This is a Jupyter notebook file which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the last file, that is signup.db file. This file is a database file which is used to store the user information. So this is about the code folder. Dataset has been opened. Let's see. So this is the dataset that we have used in this project. So here we have ID, ID of the question. And this is the title of the question. And next we have is the body of the question. Here, if you observe, we have the body of the question. So this is the body of the question. So here we have tags and here we have creation data, and the last column we have is the target column, that is low quality question, low quality edit question, or high quality. So this is about the data set. This data set we will be using for training the models. And now let's execute. To execute, we are supposed to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the command prompt. It has been opened. Give the command cd, give the space, and paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host. This is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. We need to sign up first. Click on sign up and enter all the registration details. If you are registering newly, I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. Here you can see choose file button, right? We need to click on that for uploading the test data. Click on that. We are supposed to upload this file. Select it, click on open. Before uploading, let's see what do we have in that file. Get back to the code folder, open the data set, open the test data. So here are the different questions that we will be uploading now. So these are the questions related to the errors that people get. Let's close this. Get back to the application. Now click on upload. So this given input, it will be pre-processed at the backend and then it will be fed with the train model. Then train model will be giving us a prediction. So this is the first question that we have given. Based on the given question, here we got the prediction that it is low quality question close, that is LQ close. It doesn't give a complete context. We cannot understand any problem from this text. There is no code snippet, so that is why it has predicted as low quality close. And for this given second question, this is the second question that we have given. Second test case. So for the given case, here we got the prediction that LQ close. And here for this test case, we got the prediction that LQ close. And for the next question, here we got the prediction that LQ edit. That is the lower quality edit. Similarly, for this also we have the LQ edit. And for this question, we have prediction that LQ close. And here for this question that we have given, it is of high quality question. Okay. So similarly, for all the given questions here, we got the prediction. If it is low quality question, we got the low quality close. And if it is edit kind of one, we got low quality edit. And if it is of high quality, we got the prediction as high quality. Now let's check with the graphs. Click on graph. So here the first graph which we have is the confusion matrix graph. Here on x-axis we have predicted class and on y-axis we have true class. This is the extension CNN2D's confusion matrix. And this is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained for predicting the quality of the question. And this is the precision score comparison graph. This is the recall score and this is the FN score. So accuracy, precision, recall, and FN score are the evaluation metrics used to evaluate the classification models. Now click on sign out. In this widget, by giving questions, that is programming related questions or any error related questions to this system, it will predict of which quality of that question is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.